Hello, guys. Yes, so we have this beautiful question here. Yes, so we are looking at engineering math. So, our question, we have y prime plus the expression 4 over x plus 2, or y is equal to 5 over x plus 2 all squared. Yes, so we are asked to use an appropriate method to solve this question. So looking at the nature of this question, we can simply find the integrating factor and then multiply through the equation by the integrating factor, and then from there we would see what we can do next. So without wasting much time, let's start with this. Okay, so let's see how we can express this question. So we can simply say y prime is like dy dx. So we find the integrating factor, right? So we will write it. We have y prime, which is same as dy dx. So dy dx plus p of x, p of x y is equal to q of x. Good. So comparing this equation to the equation that was given to us, we could see simply that p of x is equal to 4 over the expression x plus 2, and q of x is also equal to 5 over x plus 2 all squared. Good. So the formula for our integrating factor is e to the power integral of p of x dx. I repeat, e to the power integral of p of x dx. So you write that. Now let's just focus on the integral part. So we have integral of p of x, where p of x is 4 over x plus 2, dx. Yes. So when we integrate this, right, I said that when you have 1 over x and you are supposed to integrate, you get ln of x. So it means that for this particular expression, we are going to get something like 4 ln of x plus 2, right? So let's bring our e. So 4 ln of x plus 2. Good. And then we send the 4 to the power of the brackets so that e and ln can be in direct contact. And then when we simplify that, it's going to make the whatever is in the exponent stand alone. So let me write this. If you have e ln of x, you are going to get x. Good, x. So applying this to the question means we are going to get x plus 2 to the power 4. So this becomes our integrating factor. So now that we found our integrating factor, what we do next is we multiply through the initial equation that was given by the integrating factor. So every term there would be multiplied by the integrating factor. Alright, so let's work on that. So multiplying through everything by the integrating factor, it means that we have so you have to multiply through by the integrating factor. Okay, so for the first expression we have y prime, which is same as dy dx. So not to make it complicated here, let's just use y prime. So we have x plus 2 to the power 4, which is our integrating factor, multiplied by y prime. plus x plus 2 to the power 4 multiplied by p of x, which is 4 over x plus 2 plus 2, or y is equal to integrating factor, which is x plus 2 all to the power 4 multiplied by our q of x, which is 5 over x plus 2 plus 2, all squared. And then yes, we've been able to do this successfully. So we could see that x plus 2 is common between the denominator and then the integrating factor. So what happens is we can rewrite this y prime plus, now on this side we can break it down. Since x plus 2 is common, x plus 2 is simply like x plus 2 to the power 1. So we subtract that 1 from the power 4. So simply we are going to get 4, which is multiplied by x plus 2 to the power 3. That is when we break that part down, or y is equal to, for this side too, we could see that x plus 2 is common, so we can simply subtract them. So minus 2, this becomes x, so we have 5 there. Let's write that a 5. We have 5 into brackets x plus 2. Now when you subtract the denominator from the numerator, you get to the power 2. Alright, so we've been able to move a step. Alright, so at this point we could simply see that one is the derivative of the other. Yes, how? Let me prove this to you. So we have x plus 2 to the power 4, or y prime, and then we have 4 into bracket x plus 2 to the power 3y. So x plus 2 to the power 4 y prime, when we differentiate this term, the 4 is going to drop and you subtract 1 from the power. That is differentiation. So when we differentiate it, we get 4 into bracket x plus 2 to the power 3, and then y. Good. So we could see that one term there is the derivative of the other, right? So the second term is the derivative of the first term. So let's ignore the second term and then focus on the first term and then right hand side of the equation. So whenever you solve and then you realize one is the derivative of the other, you simply ignore the derivative and then work on the actual one. Okay, so let's rewrite this. Let's rewrite it. So at this point also we can apply our integral signs. Yes, so when we apply our integral signs, we can be able to break this question down further. Yes, and then this takes us closer to our general solution. So we have x plus 2 all to the power 4 y prime, yes, is equal to 5 into brackets x plus 2 all squared. So we can apply our integral signs here, and then when we do that, let's do that. So dx, and this one too is dy, don't forget. So we apply our integral signs to both sides, then we solve this equation. So when we apply this, we have d dx multiplied by the expression x plus 2 and then to the power 4. Yes, y prime is equal to our integral of 5x plus 2 to the power 2 dx. Good. Let's move to the next page and then write this there. Right. So whilst I erase this from here, you should note that whenever you integrate something that has already been differentiated, you are going to get the actual thing. Yes, and it's the same thing that is actually happening here when you look at the left hand side of the equation. So when we integrate that y prime, we get y, right? So let's do that. So looking at the left hand side, we have x plus 2 or y. That is when we integrate that side, then this is supposed to be equal to right hand side of the equation. So at the right hand side we have 5/3 multiplied by x plus 2 all to the power 3. Yes, I know you might be a bit confused at this part. Yes, but let me explain this to you. But don't forget to add your constant of integration. Alright, so this is how we had the right hand side of the equation. If you have something like 2x squared, when you integrate like the x, okay, so when you integrate this, the 2 is going to be divided, right? And then you subtract you add 1 to the power, so it becomes 3. So 2/3 multiplied by x to the power 3 plus your constant of integration. So that is the same thing we applied to the right hand side of the equation. So it became 5/2 plus 1 was 3, so 5/3, and then we added 1 to the power 2, so it became x plus 2 to the power 3. Now we have our constant of integration. Yes, I think you are found now. You were lost. Alright. Yeah, so let's move on. We have x plus 2 to the power 4. Y is equal to 5/3 x plus 2 to the power 3/3 plus our constant of integration. So we want y to stand alone, right? So we divide through by the coefficient. So x plus 2 to the power 4, and then here we divide through, so we are dividing through by x plus 2 to the power 4. So we have c over x plus 2 to the power 4. Alright, then now we can cancel the left hand side of the equation. So we can write this as y is equal to 5 into bracket x plus 2 to the power 3 over 3 to bracket x plus 2 to the power 4 plus our constant over our denominator plus 2 to the power 4. Good. So you can leave your answer here, but yes, you can still break it down further. And then that is what we are going for. Yes. Because you can't have 2x over x and then not cancel out the x. Yeah. So let me erase this part, and then let's solve that there. So we are just a step away from our final answer. Just a step away. Yes, so this is how you actually go about differential equation questions, like finding the general solutions and so on. Yeah, so you look at the question, then you check if you can separate the variables, then you apply the method of separation of variables. If you can't, then you see what you can do about the question. Yes, so let's break this down here. So we had y is equal to 5 into bracket x plus 2 to the power, it was 3, right? It was 3, yeah, over 3 into bracket x plus 2 to the power 4 plus our constant over our denominator x plus 2 to the power 4. So we could see that x plus 2 was common between these two terms, or yes, so we subtract. Yes, we subtract, or you can simply cancel it out, however you want to do it. It's a choice. Yeah, so if we are going to subtract, then it's going to be the 3 minus the 4, which would be negative 1. So we have 5 to bracket x plus 2 and then minus 1 plus c over x plus 2 to the power 4. Don't forget there is some 3 below the 5. Yes, so we have y is equal to 5 over so when we have x plus 2 to the power minus 1, it becomes 1 over x plus 2 to the x plus 2. Yeah, so this is supposed to be our final answer. Yes, this is supposed to be our final answer. But I think we missed something here. You will see that there was some 3 under the 5. So you will rewrite that. So it's going to be 5 over 3 into bracket x plus 2 plus c over x plus 2 to the power 4. And this is our final answer, or this is supposed to be our general solution. Yes. If you have any questions, you can drop them down in the comments section. Yes. Don't forget to subscribe and then stay updated.